7 is their 7.
Is this
Isn't it like either?
No, that should be next week.
Could it be easy to predict?
So wait, what did you say the quiz was on this? It's still distillation? Or?
Another distillation, and then a batch distillation, and then a packed.
Packed after this? Packed after that?
Packed will be after that. I think that's 30th.
So like 2 feed or like rainfall?
Yeah, something. Yeah, we're going to go up in difficulty, so this will be like the hardest distillation problem.
But it's not easy.
Not easy.
It's not what?
This week is the last distillation. Last regular.
Oh, because you have Wait, David, did he say?
Well, if you, so the question is on the first one where you have the 2 feeds, I think, right? So you figure all that out, and then you mix the feeds.
Yeah, it says last time the feeds are accidental.
So then you only have 1 feed.
Yeah.
And then that's just like a regular problem.
Yeah, I tried to do it.
And he told the first part says switching the feeds. Just do it. Says
What's the difference between the feeds? Are they different compositions?
it's the same components.
Well, no, you still have to work it as a 2 feed problem.
I told you.
Wait, what do you mean? Yeah.
But if it's the same concentration, why would it matter?
They're different concentrations.
Wait, but they're the same feed though. How do you work it as a 1 feed problem?
Since you mix them in.
Because what I was saying is you would calculate the total of this component and the total of this component, put them together, and then.
All right, what's the problem as written?
It's a distillation column. It's 100 moles per hour on the top feed at 50.5 concentration. And then the other one's 50 moles per hour at 0.3. And then the second part is the bottom feed is moved to the top, so basically they're mixed at one column or one stage. So you're gonna have 150 feeds.
All right, so part 1 of the problem is figure out the number of stages.
Yeah, that's the
First part is
Okay, so what did you get, or what's the?
I got like 16.
I got 16.
I figured it out, but I didn't.
They're really
All right, how many stages are on the top part of the column?
Like 8-ish.
In the middle?
3.
No,
It doesn't matter, we just have to have some kind of.
I just did it, and then it's like 5-ish. Yes.
That sounds good. So this won't be exact either, but it'll look something like this.
So were you asking the first part is still problem 1 or is this problem 2? Okay, because there's 2 separate, I think, that's the problem. But I was just looking at this
Something like that. Now, what's the problem if you switch the feeds?
How do you do it?
If you switch the feed, wouldn't your
Well, it
bottom
should-
line change?
Yes. Yeah. But what's the more obvious right away?
Oh, the feed ones?
The middles are messed up.
Yeah. So if you put the less, this one has a lower mole fraction of the more volatile component. So if you put that one on the top, then you've got things going all over the place.
How would you draw that on the chart? If you switch the, because what I'm saying is that the smaller composition is the same. So
Yeah.
if you switch it to that side or put it on a higher stage, like how would you illustrate that in drawing.
What do you think?
Put-
Let's brainstorm.
Put R at, I try to put the, do you put the R at the top?
Yeah.
It would affect when you can step down.
Yeah,
It
definitely.
wouldn't be optimally inserted, not be optimally placed.
Right. For sure.
But how would you step down when you hit the second feed? Because you passed it before you hit the first feed.
Yeah.
So you don't step.
It's messed
Go
up,
back.
right? Yeah, you'd have to like go
So
back.
we should just not work.
Yeah, I'm not gonna ask.
We need
Wait, how do you do it? How do you do
It's
it?
an interesting thought experiment
How do
though,
you-
right?
I think that's the point, is you can do, I think you can do the second part, because there's a second part in the first problem, and then problem 2 is a continuation of the first problem. So the second part in the first problem says they're mixed and introduced together.
Yeah, I mean, that,
And
that
you
part's
can-
easy. So all you do is you do, now instead of 2 feeds, now you have 1 feed at 150 moles
Right.
per hour.
And it's 50.
And,
43.
yeah.
Yeah.
Okay.
And then,
So
so you
that's
have
just a
that.
regular problem.
Right.
For
So
the
then that's,
purity, like how
But
do
it-
we get the purity or recovery from this?
You have to guess it.
Yeah, when we were trying to solve it, all you have is F and C.
Yeah.
You have to guess it and make sure the
I think you
steps
gotta
and the
guess.
mass balance add up.
Would it be the same steps though, considering that it's a complete different?
They tell you it's one above the top
You
feed.
know what feed is that? So I didn't find the actual numbers.
Yeah,
but
I couldn't
you know
do
it's
it.
a feed like 9-ish. And I assume that the R equals 1.25 times R min still works.
So we know it's at feed 9, but how
So you
many
just made
total
some
stages?
assumptions and then see what the stages.
Same amount of
Yeah,
stages.
Same
yeah,
amount of
yeah,
stages,
sounds
yeah.
like-
Yeah.
It's not gonna change. Because once you decide, once you figure out the total number of stages, that like that's given, and that doesn't change the rest of the problem. Now you're just moving.
I
where-
guess we just have to just go like whatever up and whatever down and try to.
Yeah, so
It's
you
not
can you-
annoying.
Keep the total
can you
number of
get,
stages and then have not feed.
well, it wouldn't be optimal anymore. It would be
Yeah.
wherever the first.
You have to keep stepping on the line that you're on.
And then, so yeah, once you finally step up to that, then you have however many stages are above it still. And then once you're up there, at the end, then you do all that. Like, because those are
We're
things
talking
you
about
can't
one
do.
basic, but how did you do mass balance if you can't find? Why is it not optimal?
Because now you have.
That was like,
Oh, you're
Because,
saying.
yeah, because you have the column built already, and all you're doing is you're switching the
see
feeds.
like what should the other.
So you have to keep 8 stages in the
The
top.
results log.
It was,
However many in the middle.
I didn't have enough like
But
graphs.
I'm
to
talking about when you
actually
mix them, so there could be no, yeah, it seemed to understand.
They go-
So
they go-
what stage do they come in on when you mix them? On the
They
top
come
stage?
in on the top.
Yeah,
So
so-
you keep the same number of stages on the top and the same on the bottom?
Yep, so in that case, then you have, in this example, you have 8 on the top and 8 on the bottom.
Okay.
And then that obviously changes your operating lines, but you still have to do your 8 stages on the one line and then 8 stages on the other line.
So then you have to guess operating lines at that point.
Because mine is-
Yeah, you'd have to, right, you'd have to guess your XD and your XP.
And then, but you also wouldn't have complete mass balance if you don't have any of the outlets. So how do you?
Well, right, but so once you guess your XD and your XP, then you know your XD and your XP, and then you can VBB it out.
Don't you know what you want your purity to be in the end, isn't it? Why not? Because, oh, now we're guessing.
Or even
Oh,
overhead purity, so you
gotcha.
can get
Yeah.
I'm just confused about.
The Ryan column was really confusing.
I couldn't do
Are we
it
done?
Yeah, are we, anything else on this?
Wait, can you show how to do if you switch the feeds?
Yeah, so it would look pretty messed up. It'd be something like, so your top section would then be like this. You'd step off your 8 stages, that's 3 in this example, and then you'd have to go backwards. Because think about what's happening. If in this part of the column, all right, I'm gonna switch.
Oh. I guess that makes sense.
In this part of the column, you have somewhere in between 0.3 and 0.5 more volatile component. So by introducing 0.5 more volatile component, you're actually making your separation worse. So that's why you have to go backwards.
Which
So
we
confused.
wouldn't know how to do.
Yeah, don't
Yeah.
worry.
That's, I think that, yeah, it's not, it would be
It's pretty
totally
abstract.
detrimental and not
Yes.
practical.
Can you explain the Ryan one?
What about it?
I drew it, but it didn't make sense. Like what was coming in was coming out. It was the same thing.
It says like eliminate the condenser and insulation. So what I'm thinking is basically just heating up the fluid and it's just all coming out the same.
This is going up and then down and out.
That's before you get started though. Like that was my original question: is can you tell us like what constitutes a Ryan problem?
So, did he tell you the story about Ryan?
I don't think so.
He might have.
Ryan was one of his students in like the 90s or something. He was a real abstract thinker, and one day he said, well, John says that he had a lot of ideas that were really out there, but every now and again, one of his ideas would be so stupid that it actually was interesting to think about. This is like his magnum opus. So he said, what if there was no condenser, but it like condensed as it went? So John's thought about it, and he said, that's a pretty good problem. So that's why it became the Ryan column. It's not like a famous guy named Ryan thought this up.
Damn, I tried to look it up on the book.
It's a dude named Ryan.
Wow.
15 years ago.
That's awesome.
That's crazy.
So the idea is that you don't know Ryan problems never have a condenser. It's always
Right. So there's
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 insulation, so it's condensing on its own. So
yeah.
Okay.
Yeah, but even
Another fun dog problem, or is it like something that you actually
No, the Ryan problem is something you do.
but like in real life?
Yeah.
Would you?
well, what's your overhead
You
problem?
probably wouldn't, because it's probably not efficient.
What's the point?
It's more tractable than switching the feeds.
What's the overhead product that you get out of it though? Because does it actually come out of it? Or does it go
Yeah,
down?
yeah. So
It
just
does?
instead of a condenser, your product just leaves.
Oh, damn.
Uh,
Wow.
That makes sense.
God damn it. Yeah.
So if you remember when I first started this review, I said the only thing you need is like some kind of reflux coming down from the top and some kind of reflux some saturated vapor from the bottom and saturated liquid from the top. So usually your condenser gives you the saturated liquid from the top and your boiler gives you saturated vapor from the bottom. But if there's no condenser, it wouldn't work unless you had some other means of condensing liquid, which in this case is a loss of insulation. So everything else is insulated except the top stages. Yeah.
So the top stages virtually all function as equilibrium condensers?
Yeah, you can think of it like that, like a pseudo condenser.
I think these ones are all insulation is limited, but
Throughout the whole column?
Yeah.
Oh, okay. Fine.
Would you assume that each stage has the same amount of condensation that comes out of it?
Well, what does the problem statement say?
Yeah, no.
Eliminate condenser feed is 100, Z is 0.5, fed to the reboiler. There's 5 equilibrium stages.
Feed is 100 at 0.5.
Yep. And it's charged through the bottom. 5 stages, and V is 150 moles per hour. And the question is predict the composition and flows assuming the heat loss condenses. Never mind. 20 moles per hour vapor per stage.
Yeah. So
Where does V go?
what's that?
Where does V go to? Just go out?
That's your product. Now notice it's not being condensed, so it's not XD, it's YD. Yeah.
How can you get steady state if your feed is less than what leaves out of your,
Good question. What do you think?
you have a negative?
Yeah, is that right? It's 100 moles in and 150 moles out.
That's what it says.
That's what the problem says.
So do we have 50 coming in at the bottom? Do we have negative 50 for our feed?
Well, you should have
There's
50
hold
going
up,
out and
maybe.
100 coming in.
Maybe there's hold up and just like.
No, but then eventually.
Well, yeah, but you have to be able to draw. You have to be, if you draw a boundary around your system,
Yeah, that's true.
you have to have mass balance closure.
Oh, it's on steady state.
Yeah.
But that would mean that it's producing liquid. Like I can see maybe if it was like holding the liquid.
Dude,
Wait,
Ryan's
does it say
genius.
V or does it say V prime?
V.
It's V prime then.
It has to be V.
That makes sense. Does it say V prime? Or does
It has
say
to be.
boiler?
It says V, but it probably.
It has to be V prime.
Yeah.
Wow, I didn't even catch that.
stages. So you could say V is 50, I think, because there's 5 stages, 20 each, right?
Yep, that's right. So, well, that's L prime is 100.
No, because you. What about?
Then you could do a balance around here that gets you 50. And this gets you 50. Well, what's,
How did you know L prime was 100?
because there's 20 coming down from each stage.
Are we given that?
Yeah.
Oh, true.
It also says 5 stages.
True.
What else is a problem?
Now we have to do mass balance to find our R.
Yeah. So the problem is you need to know your operating line. To know your operating line, you have to have your R, which is a function of the condenser. Since there is no condenser, what do we do?
You have different operating lines for each.
So you essentially have 5 operating lines.
Right. So how do you figure out their slopes?
So you just use the V prime and the L prime as your R and your L over D.
Your V prime and your what?
And your L prime. For each stage.
Okay, yeah. That sounds good. So you have to figure out the total flows. So instead of doing 20 in each stage, you're going to work it all out. 150 coming in, 20 gets condensed, so 130 is going up. 150 plus X equals 100 plus 130, so that's 80. Coming down 60, 40, 20.
You put 20 twice.
Yeah, wait, 1, 2, 3, 4, 5.
So it should be 0 at the top.
I have too many stages.
Oh.
Should it be? No, it should be 0.
Well, no, because you do it twice.
Not maybe yet.
Or should we have another stage and L prime should be one?
No, this is fine. So
Okay, because it said 5.
stage 1, stage 2, stage 3.
So yeah, at 1 is 0, right? Look what it's
Okay, so stage
And then at
5.
2 is 20.
Yeah, stages are like the 2 ones.
Okay.
Well, you can draw however you want, but that's how I usually do it.
So we're doing R as L prime over V prime.
Yeah, think about why that makes sense. So R.
We don't have an L. Start off with an L.
Right.
0.
Yeah. Yeah. So you can write, so I like to write mass balances. We'll call this L prime 1. Let's denote the flows with the stage that it comes off from. So L1, E2, L2, L3, L4. L prime is L prime. V2, V3, V4, V5, and V1 equals D. So are you given compositions or do you have to guess?
Yeah, that's what we're
Predicting the compositions? All right, well that gets tricky. So I'll make a guess. Guess a YD so that it's known. So now that's specified. Write a mass balance around stage 1. So V times YD plus L1 X1 equals P2 Y2. So in this question? No.
What is L1?
L1 is just what I called this 20. So I'm saying the L primes are all associated with the stage. That's the stage that it comes off.
So we know
So
the LM.
this is known.